Welcome, dear viewers. I hope you are all doing well, and I truly wish for goodness, peace, and health for each of you. Today, we step into a topic that has shaped both science and imagination, the Big Bang Theory. The Big Bang Theory is the leading explanation of how our universe began. It describes not just an explosion, but a rapid expansion of space itself, from a state of incredible density and heat to the vast cosmos we see today. Scientists believe that around 13.8 billion years ago, everything, space, time, energy, and matter, was compressed into a point smaller than an atom. In an instant, that point expanded outward, creating the foundation of our universe. The evidence for this theory is powerful. One piece is the observation that galaxies are moving away from us. In 1929, astronomer Edwin Hubble discovered that the farther a galaxy is, the faster it is receding. This showed that the universe is not static, it is expanding. Another piece of evidence is the discovery of cosmic microwave background radiation. In 1965, scientists Arno Penzias and Robert Wilson accidentally found faint microwave signals coming from every direction in the sky. This was the afterglow of the Big Bang, heat left over from the early universe, now cooled to just a few degrees above absolute zero. Even more, the abundance of light elements, like hydrogen, helium, and lithium in the universe, matches predictions from the Big Bang model. Right after the expansion began, the universe was hot enough for nuclear reactions to occur. These reactions forged the first light elements, and their ratios today are almost exactly what the theory predicted. So the Big Bang Theory is not just an idea, it is a framework supported by evidence from astronomy, physics, and cosmology. It tells us how space and time began, and how everything around us, from stars to galaxies to the very atoms in our bodies, emerged from that initial moment. But before we continue deeper into this journey, I want to pause here to make something clear about this channel. Before we move to our today, I want to say that this channel is user-friendly, no offensive content, no misinformation. We explain things with respect, curiosity, and authenticity. Now that we understand the basic idea of the Big Bang Theory, let's explore what happened in the earliest moments of our universe. At the very first instant, the universe was unimaginably hot and dense. This moment is often called Planck time, a fraction of a second so small that our current physics can barely describe it. Within less than a second, the universe began to expand and cool. This rapid growth is known as cosmic inflation. During inflation, space itself stretched faster than the speed of light, smoothing out the universe and spreading tiny fluctuations that would later grow into galaxies and clusters. Just a few minutes later, a process called nucleosynthesis began. This is when the first light elements formed. Hydrogen was the most common, followed by helium and a trace amount of lithium. These ingredients became the raw material for all future stars and planets. As the universe continued to cool, over the next hundreds of thousands of years, atoms finally began to form. Before this, particles like protons and electrons were free, scattering light everywhere and keeping the universe opaque. But when atoms formed, light was able to travel freely. This event is called recombination. The radiation from this era is what we now detect as the cosmic microwave background. Imagine it like this: a photograph of the universe when it was just 380,000 years old. This baby picture of the cosmos shows tiny differences in temperature and density. Those small variations became the seeds of galaxies, stars, and eventually life itself. The Big Bang Theory also connects deeply with Albert Einstein's general theory of relativity. Einstein showed that space and time are linked, and that gravity is the bending of this fabric. When scientists applied relativity to the universe, they realized it could not be static. It must be expanding or contracting. Observations later confirmed that expansion was real. However, the story of the Big Bang is not only about science facts. It is also about the human journey. To understand our origins, from ancient sky watchers to modern astrophysicists, people have always looked up at the stars and wondered where it all began. The Big Bang Theory represents our best attempt so far to answer that timeless question. The beauty of this theory is that it links the smallest particles to the largest galaxies. It shows us that the universe has a history, a beginning, and a future. We have seen how the Big Bang Theory explains the birth and early stages of the universe. Now let us explore what the universe became afterward and how scientists continue to study its story. After recombination, when the first atoms formed and light could finally move freely, the universe entered a period sometimes called the cosmic dark ages. There were no stars, no galaxies, only vast clouds of gas slowly gathering under gravity. For millions of years, gravity worked silently, pulling hydrogen and helium together. Finally, the first stars ignited. These stars were massive, hot, and short-lived, but they changed everything. They lit up the darkness, created heavier elements like carbon, oxygen, and iron through nuclear fusion, and exploded in brilliant supernovae. From their ashes, new stars formed, along with the first galaxies. Over billions of years, galaxies merged. Clusters of galaxies took shape, and the cosmic web we see today spread across the universe. The Big Bang Theory does not stop with the early universe. It also predicts that expansion continues even now, and this prediction has been confirmed repeatedly. In the late 1990s, two teams of astronomers discovered that not only is the universe expanding, but the expansion is accelerating. This was a shocking discovery. To explain it, scientists proposed the existence of something mysterious called dark energy. Dark energy is thought to make up around 70% of the universe. It pushes galaxies apart, driving the acceleration of cosmic expansion. Although we cannot see it directly, its effects are visible everywhere in the cosmos. Alongside dark energy, there is also the mystery of dark matter. Unlike dark energy, dark matter pulls things together. It acts like invisible glue, helping galaxies hold their shapes and influencing the large-scale structure of the universe. Together, dark matter and dark energy show us that the universe is far stranger than we once imagined. Ordinary matter, the stuff that makes stars, planets, and even us, is only about 5% of the total. The rest is hidden, waiting to be understood. This combination of evidence, the cosmic microwave background, the expansion of space, the distribution of galaxies, and the mysteries of dark energy and dark matter all continue to strengthen the Big Bang Theory. It remains the best explanation we have. For the origin and evolution of the cosmos, we have traveled from the first instant of the Big Bang, through the birth of atoms, the rise of stars, and the vast structures of the cosmos. But the Big Bang Theory is not just about the past. It also raises questions about the future of our universe. If the universe is expanding, where is it heading? There are several possible scenarios, and scientists are still searching for answers. One idea is the Big Freeze. If dark energy continues to dominate, the universe will keep expanding forever. Galaxies will drift farther apart, stars will burn out, and the cosmos will grow cold and empty. Another idea is the Big Crunch. If gravity somehow overcomes expansion, the universe could collapse back in on itself, ending in a state similar to the beginning. A third possibility is the Big Rip. If dark energy grows stronger with time, it could eventually tear apart galaxies, stars, planets, and even atoms themselves. Each scenario depends on the exact nature of dark matter and dark energy, mysteries that science is still working to solve. The Big Bang Theory also invites a deeper reflection. It reminds us that everything we see, everything we are, comes from that first cosmic moment. The atoms in your body were once inside ancient stars, and those stars were born from the expansion of the universe itself. So when we look at the night sky, we are not only seeing light from distant stars, we are seeing the history of creation written across the cosmos. This is why the Big Bang Theory is more than a scientific model. It is a story of beginnings, a bridge between physics, astronomy, and human curiosity. It connects us to the universe and shows that we are part of something far greater than ourselves. All the information we provide comes from verified historical sources, including books, records, and archaeology. For today's video, the scientific sources include NASA's Cosmic Background Explorer (COBE) mission, the Wilkinson Microwave Anisotropy Probe (WMAP), and the Planck Space Observatory, the works of Edwin Hubble, Arno Penzias, and Robert Wilson, and research published by the European Space Agency (ESA) and peer-reviewed journals in astrophysics and cosmology. And now, dear viewers, if you enjoyed this journey through time and space, please like, share, and subscribe to our channel, Thrones of Knowledge. Don't forget to press the bell icon to get notified on time for our upcoming explorations. And tell us in the comments what topic you would like us to cover next, so we can make your experience even better.